L'Hopital, L'Hopital's rule. This is the rule that is used to evaluate the limits of a function using the derivative. And we are looking at two special cases of L'Hopital's rule here in Calculus 1. Suppose you have a function y equal to f of x and y equal to z of x that are differentiable on the open interval containing a. That is, around a, you can find the derivative of these two functions. And z of x, or the derivative of z of x, is not 0. And if the derivative of the f of x and z of x are both 0 or even infinity, then the limit as x approaches to a of f of x over z of x. So when you try to find the limit as x approaches to a of f of x over z of x, if both of these goes to 0, then it will be 0 over 0. And if you try to find 0 over 0, we don't know what is that. Nobody knows what is 0 over 0 so far. It is indeterminate form. Or if it is infinity, if both goes to infinity, in that case, it will be infinity over infinity. So that is also, we don't know what is that value, infinity over infinity or 0 over 0. They are indeterminate form. So if you get the indeterminate form, in order to evaluate the limit, what you have to do is, this is same as limit as x approaches to a of, find the derivative of numerator, find the derivative of denominator. So f prime x divided by z prime x. And check this one. If this is still in the indeterminate form, keep finding the derivative over and over again until you remove the indeterminate form completely. So this process of finding the limit using the derivative for the indeterminate form is called the L'Hopital's rule. Example, evaluate the following limits. Part A, we have to find the limit as x approaches to -1 of x to the 4 plus x cubed plus 2x plus 2 divided by x plus 1. If you try direct substitution, if you plug in -1 into this function, your denominator will be 0 because -1, +1, it will be 0. In the numerator, it will be 1, -1, then this will be -2 plus 2, which is also 0. So if you try direct substitution, what we are getting here is 0 divided by 0 form. So make sure you write that form in the bracket like this. So this is in the form 0 over 0. So 0 over 0 form. So if it is in the 0 over 0 form, we have to use the L'Hopital's rule to find this limit. So this is equal to limit as x approaches to -1. We have to find the derivative in the numerator and also derivative in the denominator separately. So if I want to find the derivative in the numerator, derivative of x to the 4 will be 4x cubed. Derivative of x cubed will be 3x squared. Derivative of 2x will be 2. And derivative of 2 will be 0 divided by the derivative of the denominator, derivative of x plus 1 is 1. Now it is no more in 0 over 0 or indeterminate form because my denominator is 1. So this is, or by using the L'Hopital's rule one time, the indeterminate form is gone. Now we can evaluate this limit by direct substitution. Now if you try direct substitution, it will be 4 times -1 cubed plus 3 times -1 squared plus 2, which is equal to 4 times -1 cubed, -4, 3 times -1 squared, 3, plus 2, that is equal to 1. So here we use the L'Hopital's rule to get that limit. Part B, we have to find the limit as x approaches to 2 pi, and we have x sine x plus x squared minus 4 pi squared divided by x minus 2 pi. If you try direct substitution, if you plug in 2 pi for x, it will be 2 pi multiplied to sine 2 pi is 0. So 2 pi multiplied to 0 is 0, plus if you square 2 pi, it will be 4 pi squared minus 4 pi squared, that's 0. So we get 0 in the numerator, and also in the denominator, if you plug in 2 pi, it will be 2 pi minus 2 pi, that's also 0. So we are also getting 0 in the denominator. So this is 0 divided by 0 form. It is 0 over 0 form. So if you have 0 over 0 form, that is indeterminate form, So in order to find the limit in this form, we find the derivative in the numerator and derivative in the denominator separately, or we find the derivative of the numerator and of the denominator separately. So that is limit as x approaches to 2 pi. Now let's find the derivative on the numerator. So when you find the derivative here on the numerator, here we have a product. X times sine x is a product. So in order to find the derivative of this product, we use the product rule. Product rule says first function x multiplied with the derivative of second. Derivative of sine x is cosine x, plus the second function sine x multiplied with the derivative of first. Derivative of x is 1. So we got the derivative of that. Then plus derivative of x squared is 2x. 4 pi squared is a constant. Derivative of constant is 0. Divided by, in the denominator, derivative of 2 pi, derivative of constant is 0. Derivative of x is 1. Now you can see that it is no more in 0 over 0 or indeterminate form, because I have 1 in the denominator. So now I can use the direct substitution to evaluate this limit. So this is equal to the limit as x approaches to 2 pi of x cosine x plus sine x plus 2x. When you divide by 1, that's what you will get. So let's plug in. X is 2 pi, then cosine 2 pi plus sine 2 pi plus 2 times 2 pi. Now cosine 2 pi is 1. 1 times 2 pi is 2 pi. Then plus sine 2 pi is 0 from your unit circle, plus 2 times 2 pi is 4 pi. So what I'm getting is 4 pi plus 2 pi, which is equal to 6 pi. So that is the limit using the L'Hopital's rule for the problem here in part B. Example, evaluate the following limits. In part A, we have to find the limit as x approaches to infinity of this 4th degree polynomial in the numerator and also a 4th degree polynomial in the denominator. And you know that the 4th degree polynomial with the leading coefficient positive goes to infinity when x approaches the infinity. That means the numerator goes to infinity and denominator goes to infinity. So that will be infinity over infinity form. And you know that infinity over infinity form, that is the indeterminate form. So in order to find the limit, we have to find the derivative of the numerator and denominator separately. So this is equal to limit as x approaches to infinity. If I find the derivative in the numerator, 4 times 3, 12x cubed minus 2x divided by 12x cubed. And in the denominator, it will be 4 times 6 is 24x cubed. And derivative of 12 is 0. So I got the cubic function in the numerator, cubic function in the denominator. When x approaches to infinity, we know that the cubic functions goes to infinity. So that will also be infinity over infinity form. So still we have infinity over infinity form. So we have to use the L'Hopital's rule. That is, we have to find the derivative of the numerator and derivative of the denominator separately. So it will be limit as x approaches to infinity. Now, if I want to find the derivative, it will be 3 times 12, 36x squared. 36x squared minus 2. Derivative of 2x is 2 divided by, here 24x cubed. When you find the derivative, it will be 3 times 24, which is 72x squared. 72x squared. So we get a quadratic function in the numerator, a quadratic function in the denominator. And you know that when x approaches to infinity, the quadratic functions goes to infinity again. So that is again infinity over infinity form. So we have to use the L'Hopital's rule. That is, we have to find the derivative in the numerator and derivative in the denominator. So derivative of 36x squared, if you use the power rule, that will be 72x. So 72x divided by, in the denominator, and derivative of that 2 is 0. So in the denominator, it will be, if you use the power rule, 2 will come here and multiply. So it will be 144x. 144x. So what we are getting here is x in the numerator, x in the denominator cancels. And we get the limit as 72 over 144, because when x approaches to infinity of a constant, limit of the constant is a constant. So that is 72 over 144. And when you reduce that, that is equal to half. So the limit of this quantity, which is given here, is half using L'Hopital's rule. And we have to use L'Hopital rule 3 times in this case. Now part B, we have to find the limit as x approaches to infinity of a cubic polynomial in the numerator and also a cubic polynomial in the denominator. And we know that when x approaches to infinity, the cubic polynomials go to infinity. So this is infinity over infinity form. So we have to use the L'Hopital's rule. That is, we have to find the derivative in the numerator and also in the denominator. Derivative of the numerator, 3 times 4, 12x squared. Then minus, derivative of 2x squared is 4x. Derivative of 6 will be 0. So divided by, in the denominator, pi is a constant. So here we use the power rule. 3 times pi, 3 pi is x squared. 3 pi x squared. And derivative of 4 is a constant. So that is 0. Derivative of constant is 0. And you can see you have a quadratic function in the numerator, quadratic function in the denominator. So when x goes to infinity, both quadratic functions goes to infinity. So it will be infinity over infinity. So this is in indeterminate form. So we have to use the L'Hopital rule. That is, you have to find the derivative in the numerator and also in the denominator. Derivative of 12x squared is 24x. Then minus, derivative of 4x is 4, divided by, to find the derivative of this one, we use the power rule. So 2 will come in front and multiply. So it will be 6 pi and then x. 6 pi x. Now you can see we have a linear function, and here is also a linear function. And x goes to infinity, both linear functions, they goes to infinity. So still we have infinity over infinity form. So we have to use the L'Hopital's rule. That is, we have to find the derivative in the numerator and also in the denominator. So that will be limit as x approaches to infinity. Derivative of 24x is 24. Derivative of this 4 is 0. So divided by, derivative of 6 pi x is 6 pi. So we don't have any x there. So all we have to do is derivative of the constant is just that constant, which is 24 over 6 pi, which is equal to 6 goes into 24 4 times. So it will be 4 over pi. So the limit of this quantity given here in part B is 4 over pi using L'Hopital's rule.